welcome to my channel. In the previous lecture I have been talking about equilibrium in a plane. We now move to a three-dimensional and see in the three-dimensional case is the equilibrium condition leads to be balancing along on all the three axes. Let's take force F. The summation of force F equals to 0 equals to summation of Fx force is 0, summation of Fy force is 0, summation of Fz force is 0. And now take torque. Torque is summation of torque is also 0. The x direction of torque is also 0, summation of y direction of torque is also 0, and summation of z direction torque is also 0. We now have to take care the component of a force and torque in all three dimensional. The engineer elements that we considered earlier are we now consider a 3D case. This consider a ball socket joint in which a ball is supposed to be a socket supported in a socket, as you see in figure 1. A ball socket joint provides reaction force which is Nx, Ny and Nz in all three directions, but cannot apply any torque. This is little hints for 2D. Let's me solve the example using such joints. Example 1. And to balance the heavy weight is 500 Newton. To postponing a hole in the ground and point a hole a length L. Put a pole into length L so that hole acts as a socket. The pole makes an angle 30 degree from the ground and the weight instead at the midpoint of a pole and the pole pulled by two horizontal spotted at this end as shown in figure 2. Find the tension of the two poles as the reaction of force in the ground of the pole. To solve this problem, let us first choose a coordinate system. Choose it so that the pole that y-axis in the yz plane and the rope are in xy direction and the tension T in each one of them, so the tension in the written as Ti under T by under root 2 I minus T by under root 2 j and minus T by under root I 2I minus T by under root 2 j. You may be wondering why I have taken the tension and to be a same in a two rope. Actually it arises the torque and balance equation. If the tension were not equal to the component in the direction will given is non-zero torque. Let the normal reaction to be grounded Nx, Ny and Nz. The force balanced by the reaction is Fx equals to 0 equals to n x plus T by under root 2 minus T by under root 2 equals to 0. That's way Nx equals to 0. Fy equals to 0 minus equals to Ny minus 2T by under root 2 equals to 0. That's way Ny equals to T root 2. Summation of Fz equals to 0 equals to Nx minus 5000 equals to 0. That's way Nz equals to 5000. Taking the torque at a point of equation and 0, we get I t cos 30 j a plus L cos L sin 30 k into minus t under root 2 j plus L by 2 cos 30 degree j plus L by 2 sin 30 degree k into minus 5000 k equals to 0. T L under root 2 1 by 2 I minus s 200 2500 dot L dot under root 3 by 2 I equals to 0. That's where T under root 2 equals to 2 500 at under root at 3. That's where we get tension is 3062 Newton and reaction is in y direction 4330 Newton. Next, if I consider a fixed connection, say in a wall are capable of providing force along to the 3 axes is also the providing torque about to 3 axes. Thus 3D will be represented as shown in the figure. This is the generalization of fixed and welded U support in 2D. How are you torque? How are this torque it's generated? Recall what I did it for fixed a support in 2D and carry out the similar analysis in 3D. Hopefully by the analysis carried it out so far you would be able to recognize what will be reaction given in element of mechanical system can provide it. For example, look at the support shown in the figure 4 or when where the shift cannot move through the hole and fixed block, but it is free to rotate. Can you tell the reacted force of a torque is supported to provide it? Having discussed the element that apply in different kinds of force, let us took some situation there due to geometric of force applied. Some of the equilibrium equations are automatically satisfied. It will recognize this. It saves us from doing extra calculation and involving the particles condition. If the force is concurrent at a point C as shown in the figure 5, they all cross each other and 1.0. Then torque of the force identically 0 about 0.0. Thus the only equilibrium condition is summation of f0 is f direction 0, summation of y direction is 0, summation of z direction is 0. Recall that if the sum of the forces of a system is 0, torque is independent of the origin. Thus although in the beginning I used to fact that torque about 2 point it is continuous is 0. It is true about a point the force equation of equilibrium is satisfied. Next, consider that we see a force in the interaction of one particular line called z-axis without any loss of generally as shown in the figure 6. Using the transmitting force in this case we take the force Fi where I is integer number, I is 1, 2 and so on, and to acting the z k direction. Thus the torque arc due to all these forces will be tau equals to summation of I zik into f I x x I f I y j f y z k equal to summation of f z I f I y j minus f y z I f I x x I. Thus the component z component of the torque is automatically 0. In the general, when we force direct with a torque, the component as long in the vanish under the circumstances. It takes the line to be z-axis. The equilibrium condition is summation of all forces is 0. Then all direction forces are 0. Then summation of all torque is also 0. In next we discuss what happened if the applied force is parallel and say to z direction. Then the force is not have to any x component further than z component, and the torque is also vanished and let the external force. The equilibrium condition is in this case reduced. Summation of fi a equals to summation of x fx equals to 0. Summation of torque is x direction and y direction is 0. In general, the summation of all forces are 0 and summation of all torques are also 0.